Here we go, chapter 6. This whole first page right here, and this whole second page are all vocab things that we will be going over. This sheet of paper, this first sheet of paper, is a great way to start focusing on and learning vocab. But we're actually going to talk about 6.1, polygon, angle, sum theorems. So first we have to know different things like an equilateral polygon. In a polygon, an actual polygon is any shape that is enclosed and has vertices. So any shape that you could draw that is not concave. Equilateral means all the sides are equal. Equiangular means all the angles are equal. And a regular polygon is saying all sides and all angles are equal. Regular polygon, all sides, all angles are equal. So we have this right here. I would highlight this equation and this equation, these two. This first one is saying depending on what the polygon is and has the number of sides, we can figure out if we were to add up all the angles in a polygon of n sides, this is how we would do it. So this would be the total sum. It says total sum. This equation is saying if we want one angle, this equation is one angle in a regular polygon. And if we want one angle. So let's get into problem 1, shall we? It says, what is the sum of the angle measures? So in this case, it's talking about total sum. It's saying all the angle measures in a pentagon. What is the sum of it? So this is this equation. So n is going to be equal to 10 because there are 10 sides in a pentagon. So we plug this in, we go 10 minus 2. Look at how that's in parentheses times 180. The reason why this works is because we can cut every polygon into different triangles. So how many triangles? That's what that 180, because all the angles in a triangle are 180. So if I plug this into my handy dandy calculator, I would get my total sum is equal to 1,440 degrees. My total sum. Now if I look at my second question, it gives us a picture. So Marcy creates a floor tile pattern using squares, regular hexagons, so all sides, all angles are the same, and regular dodeca. Do is 2, deca is 10. So this is actually 12-sided. So this is saying n is equal to 12 for there. What is the measure of each angle in a regular dodecagon? So that's using this other equation. That's using, if I know the sides, I can figure out my total sum. That's this part right here, my total sum divided by how many sides or angles I actually have. Well, in a regular dodeca, n is equal to 12. Now I'm going to pause the video. I want you to try to do this by yourself. So here's my equation. You should get 150 degrees. One angle, so this is a dodeca right here. This one angle right here is equal to 150 degrees. That's saying all of these angles in this dodecagon are equal to 150 degrees. Now this one's a little bit different. It gives us a quadrilateral. Quad means 4. Lateral means that it has 4 sides, and actually we're going to be using quadrilateral a lot in this chapter. A lot. So first, I have to figure out, what do all these angles equal? Some of you might be like, oh, that's easy, I already know it. Well, if you don't know it, we can use our total sum equation right here. In this side, this has 1, 2, 3, 4, so that means n is equal to 4. If you plug 4 into your equation, you know that the total sum here is going to be equal to 360. That means all these angles added together are going to be equal to 360. So when I'm looking at this, I can set up the equation 91 plus 98 plus 112 plus angle D is equal to 360. Pause the video and finish solving that. And you should get angle D is equal to 59 degrees. And our last little bit of 6.1 is exterior angles. Now, this is where it's a little bit different. It does not matter how many sides a polygon has. All of the exterior angles is equal to 360. It does not matter how many sides, dodeca, all the angles, all the exterior angles. Meaning if I look at this picture, it's asking what's the measure of the exterior angle, this angle 1. First, if I'm looking at my exterior angles, that's basically going to be extending the side lengths. But you have to extend them all in the same direction. So right now I'm drawing up all of my exterior angles. If you extend the side length, notice how they're all in the same direction. I'm going counterclockwise. So these angles all added together will be 360. So when I look at this, I have to know what n is equal to. I have 1, 2, 3, 4, 5, 6. So I have 6 sides. All of these angles equal 360. So I could say 6 times angle 1 is equal to 360 because all of these are equal to 360. And if it's a regular hexagon, that means all of these exterior angles are congruent. If it's a regular, remember all of them are the same. So if I do 360 divided by 6, I would get 60 degrees. So angle 1, my exterior angle here is equal to 60 degrees because exterior angle is equal to 360. Bing, bada, boom. That's all we got for you today, folks. Have a great, grand, wonderful day.